Thank you all. All right, I'll quickly cover me, but I think I've already had a very nice introduction there, so thank you for that. I'm Scottish, so that's why my voice sounds a little bit funny. I do speak fast, but I am really trying to slow it down for everybody today. But it's a Scottish trait. We do like to speak very fast. I'm now full-time on my Rockcode Academy. Has anyone heard of my YouTube channel? Nope. All right, that means there should be at least 60 new subscribers after this. If not, it means you didn't like my talk, and I will take it personally. It's a channel that focuses on teaching people cloud native, Kubernetes, observability, and everything kind of in between. So if you're on that journey where you are adopting Kubernetes and cloud native technologies, such as Prometheus, then I hope you find it useful. I previously worked at Pulumi, which is why this talk has a bit of a Pulumi twist. It's an infrastructure as code tool that I'll talk more about a little bit later. And formerly Equinix Metal and InfluxDB. So I've been in the monitoring space for a long time, really focusing on bare metal as well with my experience at Equinix. If you want to find my YouTube channel, you can find it at rockcode.live. We also have an active Discord server available at rockcode.chat, and I'm Rockcode on GitHub, Twitter, and almost everywhere else. So if you want to learn more, come and say hello. And I'm here today to try and help us remove some YAML from our lives. Anyone that's been working with Kubernetes, and I'm going to assume it's usually the majority of the room these days. Kubernetes is a ubiquitous platform for running container-based workloads, and everyone seems to be sucked into it. But it comes with a lot of YAML. And I think there are better ways. And I want to kind of try and share some of those alternative ways to deploying workloads to Kubernetes, specifically taking a look at how we deploy and configure Prometheus. So what does the standard operating procedure look like for deploying the Prometheus operator and Prometheus rules to Kubernetes at the moment? Well, first, and don't worry if you can read this, it's all standard YAML, but you have to define our deployment. So our application has to be in the cluster, and this takes anywhere from 28 to 2,000 lines of YAML. We then expose it over a service, and already we have our first common pitfall for anyone adopting Kubernetes. Understanding label selectors and how they make our endpoints discoverable for our service versus the labels that we stick on our deployment. And when we use YAML as an interface to deploy to Kubernetes, we get something that doesn't have any guarantees that it's correct. It's very easy to kube control apply this to a cluster and not really know if that service is working without further inspection. So we want to be able to take that problem and remove it if possible. Next, if we're using the Prometheus operator, we probably need a service monitor or a pod monitor. This is another bit of glue that tells Prometheus how to scrape and set up all the targets within your cluster. Again, we have more labels. And again, there's no way to guarantee that this works until you've deployed it to your cluster and checked. So we're already seeing that there's a lot of duplication in the YAML that we've got. Next, we've got a bigger one. We've got a Prometheus deploy itself. This needs to be configured with rule selectors and namespace selectors, and it's actually bigger and not all fitting on the screen right now. So there's like 40 to 50 lines of YAML to deploy your Prometheus. A common pattern is to have one of these per namespace. So you're probably not going to just have a single Prometheus. It's not something I see a lot in production. We have multiple Prometheus, depending on your setup, how many microservices you've got, etc. But we're using more labels, more selectors to connect the dot. This is how everything in Kubernetes works. We use labels to be able to glue things together. But we don't have a good system to understand if these labels are correct. But we don't just have the Prometheus, we also need Alert Manager. We need to be able to actually understand when things or Prometheus rules within our cluster are triggering alerts. For this, we can deploy an Alert Manager, and we can also use an alpha feature for doing an Alert Manager config, which allows us to set up our own webhook receivers. So here I'm just setting up, again, you can't quite see it because it doesn't all fit in the screen, but it's just that arbitrary HTTP endpoint that will receive alerts. And we're not done. We still need to define our Prometheus rules. So this is how we actually configure the things that we want to fire when things go wrong. And this is just using the example alert, which is always going to fire within our cluster. So we're going to deploy this to a Kubernetes cluster today, but without the YAML. And we kind of tell ourselves that this is fine. Is anybody actually comfortable slinging this much YAML to production without any guarantees that what you're deploying actually works? Silence. Because it's not fine. We actually need to get better at this. Now, if you're committed to the YAML ecosystem, then fair play. You've got conf test. You can write rules and policies, but I do think there is a better way. So I am not fond of this. This is one of many Stargate memes. It's really hard to find Stargate GIFs in high quality, so I do apologize. I mean, most people in this room might have been born after Stargate was on, which also gives me the fear. But I'm not fond of YAML. We're not going to talk about YAML anymore today. I'm going to cover a little bit on the alternative tools, but really I want to focus on how do we use code to define our applications and deploy them to our clusters. And why is this not good enough? Well, we need to be able to make this better. And the way that we make this better is by acknowledging the faults. And I'm not going to say Helm is shit, and I'm not going to say customize. Can I swear? Yeah. I'm not going to say that these things are terrible, because they're really good tools. But they don't really solve the problems and the main challenges that we have with slinging the YAML to Kubernetes. These all provide either an overlay concept or a templating concept, which means all we're doing is generating YAML. And there's this common pitfall that we see with every Helm chart on the internet today. It's that the values file that we need to configure any Helm chart continues to grow and grow and grow. And it's because they're very general purpose tools that have to be able to cater to everyone that wants to deploy that piece of software. And in fact, we're now in a stage where you can go and take a look at any of the popular Helm charts on the Artifact Hub. And what you'll see is that every single YAML file, every single value is an option. So we're not really showing people an opinionated way on how to deploy things. We're not making people's lives a little bit easier. We're giving them this infinite configurable templating option. And Kustomize doesn't do a lot of templating. It tries to instead use overlays and functions, which is a really nice approach too, but we're still constrained by the fact that we're slinging YAML. We can't hook into our existing tools that we use every single day. Most people here write code, probably Python or Go, I would assume. So why not use those tools to define our infrastructure? And YTT is a bit of a weird one. It's definitely the more flexible of these tools. It came from VMware, and they have their own bespoke templating language and a whole suite of tools called the Carvel tools. Again, really interesting, but still have this exponentially configurable mess of YAML. So we want to look at other ways. So, yeah, that's just how I feel. I just love Stargate GIFs. So why don't we use a programming language? This seems like the no-brainer, and I'm going to show you that now. And maybe I put in too many of these, but I'm just going to sit and watch them. All right, so Pulumi. Anyone used Pulumi before? Okay, not a lot of you. Pulumi is an open source tool written in Go. It has two different components. One, it can consume existing Terraform providers. So if you're already in the Terraform ecosystem, you've used Terraform providers, but you want to be able to move away from HCL. HCL suffers a lot of the same problems that we see with YAML, in that it's a DSL, has very strict constraints for a reason, but we have to sometimes break out of that. This is why with HCL 0.12 or Terraform 0.12, they started to add loops and conditionals and all these other things. But really, they're moving away from a DSL and starting to provide more of a programming language. So why not just use a programming language? And in fact, Terraform and HashiCorp now even have the Terraform CDK, which gives us a as-code approach to generate the HCL. Pulumi's in the same space. It supports Java, Go, TypeScript, Python, and .NET, or any .NET and JVM language. So again, you get to use your existing tools. And my favorite thing when I do a demo of Pulumi is that I can use the language server protocol. So I don't really need to know how to code anymore because VS Code does it for me, especially with Copilot, which now does half of my job. So we get to just use those tools, we get autocomplete, we get all the powers of a real programming language with semantic awareness, which is very important. This means that we can use the same stack to provision the platform and deploy to the platform. So another trend we're seeing is that we have a lot of organizations that have a platform team that build a platform and provide SDKs to developers to deploy onto that platform. These SDKs can be as opinionated as you want within your organization to make things easier for those application teams. The other thing I really like about Pulumi is it supports server-side apply. This is a bit of a niche topic for people that are really familiar with Kubernetes, but it's a better way to deploy to your Kubernetes clusters. It's more performant and gives you more guarantees. And Pulumi supports custom resource definitions. This has been where Terraform has failed many, many times to date, and it doesn't really have a way to provide an interface or contract based on custom resource definitions. So really, you have to hook out to their escape hatch, which is to describe a custom resource and then just put in all the fields yourself with no semantic awareness. Now, we're going to run these commands in just a minute, but with Pulumi, we have a tool called CRD to Pulumi. You can take any custom resource definition that you find on the internet or for any project, maybe not anyone on the internet, but you can generate SDKs in Node.js or any other supported language, so .NET and Python. You can use a local file like crds.yaml. You can use a remote file like on GitHub with the raw URL thingy. And there's a really cool site maintained by Daniel Magnum from the Crossplane Upbound project called doc.crds.dev. You can just go to that site and paste the repository for any operator on the internet, and it will scan that repository, find the custom resource definitions, and expose them all on a single YAML file, solving that problem of, I want to use these custom resources, but I don't know where they live, which is actually very, very common. I'm also going to talk about CDKs. So this is a project that is a spin-off from the AWS CDK and the Terraform CDK, custom built around tooling for Kubernetes. It has a lot of the same benefits of Pulumi in that we have server-side apply by the fact that CDK just generates YAML. So we can just do kube control -- server-side apply. It has much better CRD support, and we'll take a look at that as well. And it has very good language support. So again, if you want to use Java, Go, and TypeScript to describe all of your Kubernetes resources, then CDKs is another very valuable option. The way it handles the custom resource definitions doesn't require an additional tool. So you don't need to use something like CRD to Pulumi, which has its good parts and bad parts. We'll cover that in a second. But we just use the cdk.yaml configuration file. There's an imports key, and again, it supports local and remote URLs there. So it's going to go away, fetch those custom resources, and actually generate an SDK locally on your machine that can be consumed within your code. So which one should you be picking? Well, I'm going to show you both. Pulumi does require a little bit more work, but it depends on what you're trying to achieve with adoption of either tool. CDKs makes importing custom resources easier, but you have to have an additional apply step, whereas Pulumi can actually do the apply to the cluster with server-side apply for you. So you get more of a full stack experience. However, you can escape hatch with Pulumi 2 to just generate the YAML if you want. Yeah, I don't know which one to recommend anymore. Like if it was 3 months ago and I still worked at Pulumi, I would have said Pulumi. Now I'm on the fence. I think they both have their benefits. If you're doing GitOps, which is very common now, we're seeing a lot more people do GitOps. It's actually very difficult with CDKs to build a GitOps pipeline because Argo CD and Flux don't really support CDKs out of the box, which means you have to have an additional step where you render the YAML, push it somewhere, and then set that up as a GitOps loop, whereas Pulumi provides an operator. So you really need to work out where you are and what you want to achieve. So now I'm going to show you both tools. So I'll just create a temporary directory. And I'm going to run CRD to Pulumi, and I'm going to generate a Go SDK. And this crds.yaml is just the YAML for the Prometheus operator. This is going to create a CRDs Kubernetes directory where we have a monitoring namespace and a meta namespace, and everything that we need to consume this SDK is here. Likewise, if we want to do Node.js, we just change the type here. And we have a Node.js SDK. So the tool's pretty easy. What is challenging here is that we can generate this on everyone's machine, and they can do it just in time, like I've just done here, and consume that from the code, and I'll show you an example. But what Pulumi really wants you to do with these SDKs is to push them to NPM, push them to PyPy, push them to Maven, and then consume them as third-party versioned dependencies. So that's already there for you. It does configure the package.json. It does configure the Maven pom.xml and so forth for each ecosystem. And we have a project at github.com/Pulumiverse where all of this is automated for you. So you can actually submit your own projects there. If anyone is interested in doing that, just reach to me in the hall and I'll kind of walk you through the process. All right. So once we have the SDKs, we actually need to start shipping some code. So I've got a few examples here. We'll start with Pulumi and TypeScript. Is that big enough for the back? Yeah. So the first thing I'm going to caveat with, this is not better yet. Right? This is still a lot of code, and our goal is not necessarily to reduce the number of lines of code, but to make sure the development experience is safer and better. So the first thing I'm doing here is defining my own Kubernetes provider with server-side apply. We actually don't need to do that, but it's just a good handy tip. I think we should be using server-side apply as much as possible. And then the most important line of code in this entire file is line 8, where we define the labels that we're going to apply to every resource. It is now not impossible, but as close to impossible as I can get to deploy a resource to this cluster where the labels are going to mismatch and not work, because I've defined them outside of the resources themselves and consuming it as a variable. Very simple, but very powerful. Next, we define a Kubernetes deployment. And you can see here, we're using our app labels on the metadata, we're using our app labels on the selector, and we're using our app labels on the template metadata. Right? Kubernetes YAML is extremely verbose. This is getting a little bit better, and that we can continue to refactor our duplication by pulling things out or hoisting them to higher level variables. Next, we define a container. This is just an example app that's instrumented with Prometheus endpoints. And then we expose it over a service. And you're going to see this all through this code, is that we're just consuming our app labels in each of the resources. What's nice here is that I get autocomplete. So let's just remove the selector, and I do selector. I don't need to remember what a service YAML looks like, because I'm using a language with a language server protocol that understands these resources. And Copilot will nicely offer to fill in the things that it knows how to do. So we can just tab our way through creating all of our Kubernetes resources. I am extremely lazy. Next, we define a service account. We have our cluster role. There's a lot of code here, very similar to the amount of YAML that we need to deploy everything. We have our role binding. We define our Prometheus. And because we have the Pulumi resource model to make us aware of what we're creating in a stack, when we're setting up the service account, we don't hard code the name. We just reference the resource that we created earlier and ask for the name. So again, we're minimizing the margin for error in our deployment. We then have our service monitor, our Prometheus rule, our alert manager config, our alert manager, and there we go, a full Prometheus stack and 240 lines of TypeScript. Wonderful. So what does this look like to deploy? Well, we can jump into our example TypeScript here. We can run Pulumi up. And we can see that it's going to create all of these resources. And I'll hit yes. This should deploy in just a couple of seconds, depending on how my network is feeling today. Awesome. So now we can run kube control, get pods, we can see the alert manager, we can see the Prometheus, we can see our application. So all of the resources that we want are now being deployed. So the first thing we could do is say, well, how do we make this reusable for other people? Now, it could be as simple as we say const deploy the thing, which is a terrible name, I know. And we just wrap all of this in a function call. Now I can ship that to NPM, and anybody can call deploy the thing. And in fact, now that we're calling this, now I can't do this twice for reasons. We have hard-coded identifiers here, so I'm not going to do it twice. But in theory, if we built this function properly and the resource with dynamic naming based on something we pass into the function, we could do this as many times as we want and as many namespaces as we want, and we get guarantees that everything is going to work. And in theory, if I run Pulumi preview right now, this should just tell us that nothing has to change, even though we've refactored our pipeline. We've refactored our Pulumi program, and we've made things a lot cleaner and nicer. Perfect. 12 things unchanged. However, this is still pretty shit. This is not a great experience. So let's delete everything. I've already prepared something inside the monitoring folder. And this has something called a magic deployment. Now, I didn't have to go look in the code. I've got my autocomplete to tell me what the exports in this function are. So let's just try and consume it. So we'll call this my deployment equals new magic deployment. And now VS Code is giving me hints on how I build this object. First, I need a name. Next, we've got some args. I don't know what those are. I pop it open. We can provide a provider and a deployment spec. Really shouldn't have deleted all that code. Let's back up a second. I don't want to have to type a deployment spec. There we go. So import from monitoring, magic deployment, paste this code. All right, so I'm going to copy our provider, because we still need a provider as part of the function spec. And this can just be passed in here as provider using short syntax. And our deployment spec is this bit here. So now I can delete everything, drop this in. And I also deleted my app labels, so app magic, sure, why not? So now there's no red squiggles, I don't think. Oh, extra comma. And things appear to be okay. So now we're not really using the Prom SDK here, but let's see what a Pulumi preview shows us now. All right. It's going to delete a whole bunch of stuff, and now it's going to create a magic monitor. I think I just got the name wrong in the class, and then a new deployment. It's actually going to do more than that, so I'm going to do the Pulumi up. Let's do a Pulumi destroy first. And then an up. Cool. So now we've got a magic monitor, a provider, and our deployment, and we'll hit go. So how do we add our service monitor and our pod monitor? How do we deploy Prometheus? Well, our magic thing, our my deployment, has some functions on it. One has got something called deploy Prometheus, and it's got something called add pod monitor. So we can just pop this open and call it, do my deployment, add pod monitor. And this takes a couple of parameters. It wants to know the port name, and it wants to know the interval that we wish to scrape the metrics. So it's the web port, and we'll do 10 seconds. Now we can run Pulumi up again. Now we get our service account, our cluster role, alert manager, and our Prometheus, and our pod monitor deployed to the cluster. So we, as a platform team, get to build these abstractions to work for our organization, ship them as packages to our application teams who don't really need to know how Prometheus works, how to configure it, or anything else. They just consume the functions that we define. Now, if we run get pods, we'll see that we have an alert manager, we have our Prometheus, and let's do a port forward, service Prometheus operator, which runs on port 9090. Oh. It's operated, not the operator. Oops. And now we have our Prometheus instance here, and we don't have our alert. So let's just skip over that. I'll do a quick bit of debugging, because why not, and see what I broke. Prometheus rules. We didn't deploy a Prometheus rule. So let's take a look at this monitoring index quickly, just to see what's in here. We can see that we have something called a component resource. This is a way that we can group things together with Pulumi. It gives us a nice tree when we do the Pulumi preview, so you would have seen a slightly different output there. And we provide a constructor which does a little bit of glue. So here we just record that we want a deployment, and we do it here. And then we can add whatever functions to this component resource that we want. So our pod monitor creates a pod monitor here, And then our deploy Prometheus does our service account, our cluster role, our role binding, our Prometheus, an alert manager. Yeah, I did forget a Prometheus rule, so that's just my bad. I'll add that in. This code will all be available on GitHub, so if you want to experiment with it and play with it yourself, you can. And I'll post a link onto Twitter just after the session, but we are very close to the end now. So Pulumi gives us the ability to build these component resources and ship them, and you can do the same with CDKs. So if we take a look at our CDKs here, we can import our paths. The TypeScript one I've already configured to pull in our CRDs here. And this gives us an imports directory. And if we pop open this, we can do kube deployment. These look extremely familiar. And it's because they're all generating the exact same TypeScript types from the same CRD definition. You can actually just copy and paste the code from CDKs to Pulumi. You only need to change one or two things, and it will also just work. So you don't need to worry about being too tied down or embedded to either one. Find the one that works for you and take it. You can see here the Prometheus one is pretty much the exact same too. So in summary, programming languages doesn't mean less lines of code, but it does mean more flexibility, more power, and stronger abstractions with less margin for error. You can use your existing tooling, VS Code, Vim, Emacs, and LSPs to give you a really rich experience to building these resources, even when you don't know what the full spec looks like. They're also extremely testable. You can actually use Jest and TypeScript to write tests against the resources that you're creating. Your deploy Prometheus, you can say, I expect 4 resources. I expect to see a Prometheus kind and an alert manager kind. Very easy to do that when you use real code. And lastly, it's distributable and shareable. So anyone can build and share and use the abstractions that you build. Thank you very much for your time.